Okay, continue with the completing the square. Okay, we know that ax squared plus bx plus c, which is the quadratic polynomial form, okay, and it equals to, when you take the a parenthesis, a times, okay, x squared plus b over a times x plus c over a. And after that, we want to complete inside of the parenthesis to the square, okay, so we must add some values, okay, x squared plus b over a x, okay, and plus b squared over 4a square, okay, and the plus c over a minus b squared over 4a square. This part, when you add these two parts, okay, it will be equal to 0. So this part will be completed to the square, and the x plus, okay, and the b over 2a square plus 4ac minus b squared over 4a. This is the general form of the completing the square rule. And the example, evaluate integral 1 over square root of 2x minus x squared del x, okay, and in the denominator part we have no form of the inverse, tangent, secant or sine form. So okay, we must complete the square, okay, to the denominator part of the integral, okay, and what will we do? Okay, del x over square root of 2x minus x squared, it equals to integral del x over square root of 1 minus, okay, and the 1 minus 2x plus x squared. As you see, I have just add and subtract 1, okay, at the denominator part. So our denominator part will be del x over square root of, okay, 1 minus x minus 1 square, okay, and let's choose u by x minus 1. So del u will be del x, and the integral del x over, I'm sorry, del u over, of course, del u over 1 minus u square, and it's equal to inverse sine u plus c, okay, and totally we can say integral del x over square root of 2x minus x square, it equals to, okay, inverse sine, okay, x minus 1 plus c. Other inverse substitutions. Example, evaluate integral 1 over 1 plus square root of 2x del x, okay, and let 2x equals to u square, so x equals to u square over 2, so del x equals to, okay, 2u over 2 times del u, and this part will be cancelled, and del x equals to u times del u, okay, and the integral 1 over 1 plus square root of 2x del x equals to integral u over, okay, 1 plus u times del u. Okay, now u plus 1 minus 1 over 1 plus u del u. As you see, I have just add 1 and subtract 1, okay, so nothing will be changed after that, we know that, and the integral u sub 1 over u sub 1 minus 1 over u sub 1 del u, okay, and after that integral del u minus integral del u over u plus 1, and it's equal to u minus ln absolute u plus 1, okay, so it's equal to square root of 2x minus ln absolute 1 plus square root of 2x plus c, which is the result. Okay, and the example again about the other inverse substitution. And the integral from minus 1 over 3 to x over cubic root of 3x plus 2 del x, okay, and let 3x plus 2 equals to u cube, okay, and after that del x equals to, okay, I'm sorry, 3 del x equals to 3u square del u, and the del x equals to u square del u. And the integral from minus 1 to the 3, okay, and after that to the 2, okay, and the u cube minus 2 over 3u, okay, and the u square del u, okay, and this part will be cancelled, and after that when x equals to minus 1 over 3, okay, let me change the endpoints of the integral, okay, and the evaluation values will be changed. So when x equals to minus 1 over 3, as you see, and the u will be, okay, and the 3 times, okay, minus 1 over 3 plus 2, okay, and the equals to, I'm sorry, u cube, okay, and the u will be 1, and after that when x equals to 2, okay, so u will be 2, right, and the our integration boundary will be changed. It starts from 1 to the 2, okay, and the u to the power of 4 minus 2u, okay, and the 1 over 3 del u, 1 over 3 times u to the power of 5 minus, okay, u square from 1 to the 2, okay. Do not exchange these values, okay. If you forget this, your result will be wrong, okay. So 16 over 15 will be result. Integrals of rational function. Integral p of x over q of x. These are polynomial functions, del x, okay. So p of x equals to a sub n x to the power of n plus a sub n minus 1 times x to the power of n minus 1 plus it goes on like that, a1 x plus a0, and we know that a sub n does not equal to 0, okay. That's the n degree of polynomial function, and the example, okay, evaluate integral x cube plus 3x square, okay, over x square plus 1 del x. If the numerator part's degree is larger than the denominator part, so you must divide each of them to each other, okay, and that means x cube plus 3x square, okay, divided by x square plus 1, okay, and the x, this part will be x cube plus x, and the 3x square minus x, okay, and the plus 3, and so 3x square, okay, plus 3, okay, so this part will be, and the minus x minus 3, okay, so we can write this integration x cube plus 3x square over x square plus 1 del x equals to, okay, and the integral x plus 3 del x minus integral, okay, x over x square plus 1 del x, okay, and the minus 3 times del x over x square plus 1. Okay, and as you see, this part is here, this part is here, and this part is here. Okay, and after that it equals to, okay, and the x plus 3 integration, it will be x square over 2 plus 3x, okay, and minus 1 over 2, okay, ln of x square plus 1, and the minus 3 times inverse tangent, okay, x plus c. And let's continue. Evaluate integral x over 2x minus 1 del x. As you see, both of them degrees are 1. So what will we do? Okay, and the x over 2x minus 1, okay, it's equal to 2 over 2 times x over 2x minus 1, and it's equal to 1 over 2 times 2x over 2x minus 1, and it's equal to 1 over 2 times, okay, and the 2x minus 1 plus 1 over 2x minus 1, okay, and after that 1 over 2 times, okay, and the 1 plus 1 over 2x minus 1, okay, so that x over 2x minus 1, it equals to 1 over 2 times 1 plus 1 over 2x minus 1. And the integral x over 2x minus 1 del x equals to 1 over 2 integral 1 plus 1 over 2x minus 1 del x. Okay, and for this part, if u equals to, let 2x minus 1, so del u equals to, okay, 2 del x, and after that x over 2 plus 1 over 4 times ln of absolute 2x minus 1 plus c. And of course we have just seen if the numerator part is larger than the numerator part, and or if numerator part's degrees equals to the numerator part. Now the basic problem, you know that the basic problem evaluation of integral p of x over q of x del x, okay, where the degree of p of x is less than the degree of q of x. Okay, it's easy. And let me show you this basic problem's solution, okay, to understand. And that means linear and quadratic denominators Okay, turn back to the basic problem, and if q of x equals to ax plus b, basically it's a line equation, and the p of x equals to a c constant. Okay, so that means integral c over ax plus b del x, okay, it's equal to c over a integral del u over u, so it's equal to c over a times ln absolute u plus c. Okay, of course, if u equals to ax plus b, and if c equals to 1, so integral, okay, 1 over ax plus b del x equals to 1 over a ln of absolute ax plus b plus c. If q of x is not a line equation, if it is a quadratic, that means like x squared plus a squared, so p of x equals to ax plus b, okay, and let me give you some example about that. X del x over, for example, x squared plus a squared, like that, or x del x over x squared minus a squared, or another form, del x over x squared plus a squared, and integral del x over x squared minus a squared. The case of a quadratic, denominator integral x del x over x squared plus a squared, can say it's equal to 1 over 2, okay, ln of x squared plus a squared plus c, integral x del x over x squared minus a squared, okay, it's equal to 1 over 2 ln of x squared minus a squared plus c, integral del x over x squared plus a squared is equal to 1 over a, okay, arctangent, okay, x over a plus c, integral del x over x squared minus a squared equal to 1 over 2 times a, okay, ln absolute x minus a over x plus a plus c. And let's continue with the fourth part, okay, to understand it. And that means 1 over x squared minus a squared equals to, okay, 1 over x minus a times x plus a, right? And after that it equals to a over x minus a plus b over a, and b are constant, okay, x plus a. When you multiply by this part x plus a and the x minus a, and you will obtain 1 over x minus a times x plus a equals to ax plus a small a plus bx minus ba over x minus a times x plus a. As you see, these parts equal to each other. We must look for this numerator part. And what can we say? Ax plus aa plus bx minus ba equals to 1. So a plus b times x plus, okay, and the aa minus ba, it equals to 1, okay, and we know that a plus b equals to 0, and the aa minus ba equals to 1. So a equals to 1 over 2a, b equals to minus 1 over 2a, and our integral will be del x over x square minus a square equals to, okay, 1 over 2a integral del x over x minus a, and minus 1 over 2a integral del x over x plus a. And look at this two part. This is capital A, and this part is capital B, okay, and so it's equal to 1 over 2a, okay, ln of absolute, okay, x minus a over x plus a plus integration constant, okay. And the continue with the partial functions. Q of x equals to x minus a1 times x minus a2 times and the x minus an, and the ai does not equal to aj if I is not equal to j and the I is larger than or equal to 1 and the j is less than or equal to n, right? And the p of x is a polynomial of degree smaller than n, and the p of x over q of x equals to a over x minus a1 plus a2, this is a sub 1 over x minus a2 plus it goes on like that, and the a sub n over x minus a sub n. Okay, this is the partial fraction decomposition. Okay, and for certain values of the constants, which is the capital A1, capital A2, and the capital AN, okay, and we don't attempt to give any formal proof of this assertion, of course, and such a proof belongs in algebra course. You will find of them, and we interest to evaluate this integration, okay, and sorry, that means x minus aj times, okay, p of x over q of x, okay, and you will obtain a1 times, okay, and the x minus aj over, okay, x minus a1, okay, and the plus, it goes like that, a j minus 1 times x a minus aj over x minus a j minus 1, okay, and the plus a j plus 1 times x minus a j over, okay, x minus a j plus 1, okay, and here must be, of course I forget, plus a j, okay, because of x minus a j over x minus a j will be 1, so reminded a j only, okay, and the plus, it goes like the plus, and the an times x minus a j over, okay, x minus an. All terms on the right side are, okay, 0 at the x equals to aj, except the j term aj, okay, so aj equals to limit x approaches to the aj, okay, and the x minus aj times p of x over q of x, which is the left hand side of this, and so it's equal to p of aj over aj minus a1 and the aj minus 1 times, okay, and the aj minus aj plus 1 aj minus an, okay, and for this interval, and let me give you an example. Evaluate integral x plus 4 over x square minus 5x plus 6 lx, and the x plus 4 over x square minus 5x plus 6 equals to, okay, x plus 4 over x minus 2 times x minus 3 equals to a over x minus 2 plus b over x minus 3, x minus 3 times x minus 2, okay? And the first method x plus 4 over, okay, and the x minus 2 times x minus 3 equals to ax minus 3a, okay, plus bx minus 2b over x minus 2 times x minus 3, okay? And after that, for the first method, okay, and the a plus b equals to 1, okay, and the minus 3a minus 2b equals to 4, okay, and when you solve this equation, okay, and the a will be minus 6 and the b will be equal to 7, okay, and of course you can check, okay, this part, and after that integral x plus 4 over x square minus 5x plus 6 del x equals to integral, okay, a times del x, which is minus 6 del x over, okay, x minus 2 plus integral, and the b times del x, which is 7 times del x over, okay, x minus 3. So that's equal to, okay, and the minus 6 times ln of absolute x minus 2, okay, and the plus 7 times ln of x minus 3 plus c, which is the total result. And